Welcome. Thanks for joining us today. And before we get to the DeltaForce demonstration, just wanted to let you know we've got a guest speaker today, Richard Stiennon. He is a cybersecurity industry expert, currently the chief research analyst over at IT Harvest. And he's going to speak a bit about how software is currently eating the world. Richard has spent several industry roles with PricewaterhouseCoopers, Gartner, as well as Fortinet, and he is the author of Secure Cloud Transformation. So Richard, if you would.
Perfect, Sam. Stan, thank you so much, and welcome everybody. I'm going to actually give you a brief presentation based on a couple of the books I've written. And we're going to start talking about software eating the world. So if, I'm sure you've heard the phrase software is eating the world, and the question I pose is, if it's eating the world, then we have to get it right, and we're exposed to some significant risks. The quote is credited to Mark Andreessen. He wrote it in a opinion piece in August of 2011 in the Wall Street Journal. So, is it eating the world? I don't know. Let's check. According to this graph, which is U.S. Investment capital expenditures in hardware and software all the way back to 1960, where in the 60s, of course, you spent all your money on the IBM mainframes and very little on the software. But obviously that changed leading up to the dot-com boom. And after the bust, represented by that thin gray bar there, in 2001, hardware sales fell off dramatically. So that was, leading up to that was Cisco and Sun Microsystems and all the rest, people buying their own servers. That started to fall off, and software took a little dip too, but then software started its trend upward. And probably in 2016 is when software investments exceeded hardware investments. Not a big surprise. Now, the trouble with software investments, especially ones that were started years ago, such as the software on a Air Force project, which probably started 10 years before the software was put in production, they don't spend much time worrying about either software quality or security. And there's one test that the Air Force did of 3 million lines of code. They took a code scanner and applied it to it, and they found a software vulnerability per 8 lines of code on average, and a critical vulnerability, meaning one that would give a remote hacker access to control the software solution in every 70 lines of code. So pretty good example of the dangers of poor software development practices. If you apply that to the F-35 Joint Strike Fighter, which has 9 million lines of code on board, that could mean 128,000 critical vulnerabilities that an attacker in a theater of war, a battle going on, could do code injection or some other way to take over control of critical systems on the jet fighter. And on top of that, and probably a much more logical target for an attacker, is the 15 million lines of code in the elaborate logistics system that was built to supply all the components and support all of the F-35 Joint Strike Fighters in the field, which the U.S. is busy selling to many of its friendly countries. So what could possibly go wrong? Well, that experience inside the military kind of puts them about 10 years behind just about everybody else, because everybody else has been going through much faster development cycles. So they've discovered the vulnerabilities, they're starting to address them, but there's still probably more legacy code out there than new code that's been done with security built in. So back to Mark Andreessen. In his op-ed, he said that 6 decades into the computer revolution, don't forget this was in 2011 timeframe, and 4 decades since the invention of the microprocessor, and 2 decades into the rise of the modern internet, all of the technology required to transform industries through software finally works and can be widely delivered at global scale. And of course, he was talking about the early days of the cloud. So to check him, I went back and looked at all the companies he mentioned as examples of software companies. And he cited Apple, Microsoft, Google, and Salesforce. So I looked at their market cap in 2011 and compared it to when I put the slide together on October 18th. And sure enough, Apple, Microsoft, and Google have all quadrupled in size. Salesforce is actually quintupled in size in that time frame. So of all those, the one that's a pure software play is Salesforce. And if you had invested based on Andreessen's comments, your IRA anyways would be in pretty good shape today. So borrowing from my Secure Cloud Transformation book, I took the book follows a story of 17 CIOs, CTOs, CISOs, and each of them at companies like Siemens, Schneider Electric, a cool company called National Oil Well, Barco, NOV, Pulte Homes, Kelly Services, Fannie Mae. Each of them went through the same journey. They took slightly different paths along the way, but it's pretty easy to winnow out a overarching story for all of them. And it began with application transformation, which is the topic we're talking about today. So I figured I'd extract some of what I was talking about. There's no question. And when I get in front of an audience, I've presented this at RSA a couple of times, quiz the audience. It's kind of a trick question. I'll say, whose organization uses software as a service? And obviously everyone has to raise their hand, right? Because there isn't a company in the world that doesn't use some form of software as a service. And that's because the logical place for software is as a service and in the cloud. So your PeopleSofts and Microsoft Exchange and Oracles and Siebels and SAPs have all made this transition already. So they are cloud apps consumable on a per person, per month kind of contract, and only as needed. So the three stages of application transformation start with that software as a service. And the most of us who've been through the purchasing cycle with choosing one of these solutions, we've gone through this list. We know that there's low to zero development costs, right? You just click a button and roll your people, provide a credit card if you're a small business like me, provide a purchase order if you're a big company, and you're up and running. Literally the same day, everybody has access to the application. There's no software licensing. There's no support for the software license. It's just usually a per person per month, billable in advance for 3 years, but it's still a huge investment. But none of the software licensing and asset management that goes around that for years and years. One of the things that I think is important is that there's no server configuration or management. Anybody who's been around in a data center for a while knows the word comes down that we've got a new application we have to support. So the engineering team has to scope out what that server is going to look like. How many cores, how much memory, how many, how does it attach to the network attached storage. All that configuration stuff is taken away from us when we go with software as a service. You mentioned the easy deployment. And mind you, it was at Gartner, and Gartner's kind of credited with creating the concept of total cost of ownership. They built a good consulting practice out of doing those calculations. If you take everything into account, including those server deployment and management costs, you can argue that software as a service is lower total cost of ownership. You could argue the other way too, I'm sure, if you were trying to make the opposite argument. But I think most people would agree that makes more sense to have a ongoing expenditure and expense essentially instead of a capital investment that you then have to depreciate, at least on the hardware side. So that's stage one, and most organizations are well down this path. Stage two is the refactoring component, and I think relevant to what Stan and Avi are going to be talking about after me. And typically, organizations will look at they've decided they want to use cloud applications, so they're going to start looking at also moving their own applications to the cloud. And lift and shift is a common term for that. And it simply means hosting apps that are already web enabled in the data center, moving them to the cloud. So you move them to Amazon AWS, or you move them to Google Cloud Platform or Microsoft Azure, or one of the hundreds of others of cloud offerings, which are basically remote data centers for you. And it's easy to do if you've already been through a process of virtualizing your data center, right? If you started to go to standardized platforms with multiple VMs running on standard hardware, then it's pretty easy to say, you know what, let's move this to the cloud and provide the security around it as we're doing it. But when you're done, you don't have the security around your data center to worry anymore, right? Your cores and your applications are running in Google's or Amazon's huge data centers that have pretty good physical security. But the other thing is, if you've decided that you, one, can't lift and shift, then you start down the process of partial refactoring, which it usually means moving the front end, the user interface, to the cloud, because you can always do with a better user interface, so you might as well recreate it, move it to the cloud, but leave the application server and the database server back in your data center. And finally, full refactoring, which is, I initially thought, when I was talking to people, that this meant, hey, we're going to, take the documentation for the original COBOL or Fortran or crazy mainframe software that we had, and we're going to completely redesign it to do all the same stuff in the cloud. And I found, over the last year, that what actually happens is they don't have documentation for the COBOL programs that they have. They don't actually know how it works. They just know that it's a black box. You enter a whole bunch of data on the screen and it gives you the results. And nobody has looked at everything that it actually does. So most organizations actually start over with designing a new application for the cloud so that they can eventually shut down those data centers. The final stage I saw these organizations go through was getting to the point where they're ready to kind of declare that they're a cloud-first organization. And cloud-first doesn't mean everything's in the cloud, we're not going to ever do anything else, but it means that every time you've got a new project, you've got an application you want to roll out, you ask yourself, will it be better in the cloud? Will it be cheaper? And will it be more secure? And if the answer to all those questions are yes, then you move it to the cloud. If it's not better, if it's more expensive and it's not as secure, then keep doing it the way you've always done it. But that's a pretty important moment for companies that are on this digital transformation journey, is when they get to the point where they can say they are cloud first. And one of the lessons that I pulled out of talking to all these people, and in particular Jim Fowler, who was the CIO at General Electric at the time, is he introduced me to the idea that cloud instances introduce standardization. And he lived through decades of having a different, even a different OS for each application. Some would run Linux, some would run, open source Linux, some would be Red Hat Linux, some would be BSD, and some legacy systems are still running on Sun, or I still run into banks that run PDP-11s. So you'd have a multitude of hardware configurations, OS configurations, and then the software versioning that runs on them. And that leads to, security issues, support issues, maintenance issues. There's whole companies that just go out there to discover what you actually have and help you keep track of that and identify when a particular contract is due to be expired or has expired, or it hasn't expired, but you've stopped using the product. So you're paying on software support licenses that you don't need. So with the cloud, we now have standard infrastructure. When somebody wants to spin up an app, they just choose, what size of instance they want to run on AWS EC2, and and that's it. And maybe you pick the OS that you're going to run, but there are only a few choices for that. So I think the infrastructure has been standardized, and we're already starting to see the positive benefits from that. Everybody knows what they're working with, less learning curve. You don't have to move platforms as often. But there are other things that we should be standardizing. The tools we use to develop our software, the development process should be standardized. And then the procedures we use for auditing and maintaining that software and rolling it out in an effective way, that is what I think of as DevSecOps, the whole process of doing all those things, standardization. But we're going to have some challenges as we do that. One is auditing. As an auditor comes in and they want to check to make sure that the right processes are being followed. There might be frequent audits for different purposes. So there might be an internal requirement. A partner or a business customer might want to audit you for following the processes that you say you do in your contracts. And then, of course, outside regulators are going to demand audit results as well. So the poor software development team has to deal with these multitude of requests, all asking for slightly different things. So managing the audit requests is a big problem, big challenge for most organizations. You've got multiple sources of information for the audit work. There might be check boxes on an Excel spreadsheet, very similar to the ones I used at PwC when I was doing security audits, and I would check, so I was responsible for actually creating the controls for third-party network connections as well as firewalls. We had a little Excel database that we used, but there could be just screenshots demonstrating that, yep, that we checked the code and the user interface still does this, plus paper copies. And then the process that it takes after an audit has revealed problems, you've got to keep track of whether or not the problem has been remediated or compliance violations, security vulnerabilities have been addressed. And there's a multitude of tools available for doing that, but that's one of the bigger issues that companies run into. Other challenges in DevOps are multiple products people have available to them for not only auditing, but managing the development process, submitting and committing the code and then getting it into production. Most organizations still use kind of a manual process for that. Of course, the goal is to have it completely automated. That code is committed, audited to make sure that the changes are acceptable, and then automatically moved into production with, they call it hands-off production, right? The different groups are different levels of maturity. Might be, the group in Southeast Asia is in a different place than the group in Sunnyvale. So you got to manage those different capabilities and your expectations of what they're going to be able to provide. And then a siloed approach to development and implementation is still the issue that the whole DevOps movement was created in order to get rid of that siloing. So everybody's pulling together to get to the same spot. And one thing that I didn't have a slide for here was this configuration creep, I guess. So once you've put something in production, the developers or support people might make changes to the production code without ever going back through the DevOps cycle again. So they've changed configurations so that, when it's running in one Amazon instance, it might actually be different from another. And doing that code comparison to find out what changes have been made would be super valuable. So I'm going to leave you with just these 3 points. I always feel bad asking somebody to inventory anything because I know how difficult that is. And in the security world, we say, categorize all of your devices, find all your laptops and desktops and assign security weightings to them, et cetera. And that's almost impossible. But everybody I talked to for my book actually went through this process. They inventoried the apps that they use. And there's some tools you can use to monitor your network and actually tell you which apps are being used and identify where they're located too, for that matter. And once you've inventoried all your apps, found all your code, and so looked at all your code repositories wherever they may reside, and unfortunately a lot of times they reside on the developers' laptops, and figure out what code that you've invested all this money in. That's when you can start prioritizing the move to the cloud, which could be lift and shift or some form of refactoring. And finally, to build change management into your DevOps cycle. And I think most organizations don't even do this, right? They might have a bug tracking and a change tracking solution that they're using, but there's no going back and making sure that the code was actually changed in the way it was supposed to be and other issues weren't introduced during those changes. So after that, I'm going to turn it over to Avi Jenik, who is going to give us a demo of how DeltaForce does that change management and code analysis and discovery.
Richard, thanks very much. I will first give the floor to Stan. Stan, would you like to give a quick brief introduction to DeltaForce, and we will jump right into the demo right after that.
Yep, absolutely. Be glad to. Thank you, Richard. Thank you, Avi. Let me go ahead and share out my screen here. All right, perfect. Hopefully you see the DeltaForce application government slide. Is that working for everybody?
Absolutely.
Okay, excellent. Essentially, what is DeltaForce? DeltaForce is an intelligent application analytics solution. And first of all, my name is Stan Yee. I'm an account executive here at DeltaForce. And in my day-to-day activities, I speak with many of the application development teams, managers who are dealing with a lot of the challenges that Richard described in great detail in that introduction. So what DeltaForce hopes to do is address these challenges specifically with our tool. Now, DeltaForce is an enterprise application analytics solution designed specifically to help provide actionable, in-depth visibility into the entire application environment. How we start is with a deep discovery of your source code files and database schema. With our patented technology, we analyze that information, provide an application repository, which serves as an on-demand reference tool for your team. We provide heterogeneous environment support. So with 60+ parsers, we can help identify various languages, frameworks, job schedulers, databases, and more. What this does is helps allow you to visualize all cross relationships between heterogeneous technologies. And specifically, how do we help? Here's a brief synopsis of some of the capabilities. So effective application change management. Customers report back to us increases in development productivity and maintenance from 30 to 75%. Refactoring applications for cloud migrations, helping to improve functionality and maintainability, remove code smells, etc. Rapid application understanding. So being able to quickly visualize all of your application assets, helping to document legacy code bases, including COBOL. Having to understand, maintain, and build upon code written by someone else is really no easy task, as any developer can tell you, and is very much a productivity killer. So what DeltaForce helps to do is helps developers get up to speed quickly, preventing system failures through on-demand change impact analysis. We all know that making changes is inherently risky, so DeltaForce displays all objects where a component or code is changed. This allows developers to determine the true scope of what is affected by application or database changes. And one of the key factors and benefits of DeltaForce is automatic documentation. Now, we all know that documentation quickly becomes outdated basically as soon as it's created. So with the application repository, your developers will always have access to the most up-to-date documentation at their fingertips. And another side benefit is improving onboarding. and knowledge transfer to all new team members. So the ability to get new employees up to speed, perhaps a tenured veteran developer leaves the company for whatever reason, and you need to quickly get people up to speed on what they've been doing. DeltaForce helps address that. So those are some of the capabilities of DeltaForce, and without much more talking, let's actually show you what it looks like. And here to give us a functional demo is Aviram Jenik.
All right, thank you very much.
Sure.
Stan. Let me go ahead and share my screen. And so hello everybody, my name is Avi Jenik, and I will go through a functional demo of DeltaForce. The main points that I'd like to go through, and going back to what Richard described, is how do we do some of the essential things around application analytics, and that is getting the inventory, so figuring out what we have, maybe producing documentation. So inventory is a more dynamic way to analyze what's going on in the software, and documentation is a more static way. And that's also important, sort of a snapshot of what's happening, what exactly is going on around our source code. I'll talk about how that can be used for refactoring, and then I'll talk about code quality and how we analyze that. So DeltaForce is essentially a static analysis tool. What we do is we take the source code. Again, it's a static analysis tool, so we don't necessarily need the source code to run. We don't even need the entire source code. Whatever we get, we run it through a semantic analysis engine. We can do it periodically. That's the ideal way to do it, is to integrate DeltaForce with the code repository, like GitHub or wherever you use to store your code. Run it periodically, daily, weekly, monthly, or at every build. And with that, we save in our internal database information about the product. So we run the semantic analysis engine, and we store everything we understand about the product, or about the program. And this means, and we do have a very, very long series of languages we support. So a lot of legacy code support for things like COBOL and Fortran, a lot of other languages that we support, down to .NET and Python and Perl and the more modern languages. So we can analyze all of them, and then since we store in our repository what we understand from the source code, we can take multiple different source code files and still give you information about them, about their relationships, about their quality, about producing documentation about them. So they don't all have to be written in the same language. And the information you get, so this is a dashboard, and this gives you a very quick snapshot of what is it you can expect to see on an ongoing basis. So the first thing that DeltaForce is a change management tool. So since we read the source code periodically, and I should mention that the semantic analysis tool is a differential analysis tool, which is why we call it Delta. This is a Delta from DeltaForce. That means we scale up to very large projects where we'll only analyze the changes between those periodic reviews. And we can give very high level information to a manager who's not necessarily very technical. So things like, what has changed? So if I'm managing a few projects, what are the most changed projects, and what is the percent of change in those projects? Down to the program or even the source code level. Everything we do can be on a project level, on a program level, application, or on an object level. What are the trends? How many files were modified? How many lines of code were modified? and then things that are around code quality. So since we do a static analysis, we basically check the files line by line. We can do things like give you what is the comment ratio in the files, are they commented enough, which files are not commented, do you have different languages that suffer? So in my case here, my Java source files are pretty well commented. My JavaScripts are also, the comment percentage is pretty good. And then it falls off to the Python, which is very not the comment ratio is very, very low. So that may or may not be good depending on your own policy. And as we go in, and some other high level dashboard graphs, complexity. So when we do refactoring, there's a couple of things we need to keep in mind. Number one, we want to know which files are less complex. So we want low-hanging fruit. If there's a file that's easy and simple, that'll be an easy refactoring process that we can do. If it's extremely complex file, we might want to break it into separate files. Maybe we've got one file or one object that does too much, and I'll show some things we can do on an object level in a little bit. And then source code quality. So this goes more directly into quality violation rules that we have. So when we analyze the code, and again, it's a semantic analysis, we try to look for certain patterns that we know are not good. And I'll show some of these. So this shows what we call quality violations. We've got a lot of rules, quality rules that we check for, and we'll show you which lines are not so good, and provide recommendations how to fix them. And again, some trends and analysis. And since we're doing all of that, we'll also flag security vulnerabilities. So DeltaForce is not meant to be a full-fledged SaaS security analysis tool, but we do flag security violations since we've got access to the code and we do understand security vulnerabilities. So things like cross-site scripting, SQL injections, information leaks, we'll highlight that. Now, everything here can be drilled down to the specific line of code level, again, because we've got all of that stored. So this was sort of the high level. Let's jump a little bit deeper in. The first thing I want to show is the relationship analysis. So as we refactor code, and also as we try to understand the code, so these two things usually go hand in hand. We want to understand what our code does, right? What are the different objects? What are different functions? How do they relate to each other? Both between objects and between an object and database. Database is really important because if we want to change from an Oracle to a cloud-based database, for example, we need to know what writes and what reads from that database, maybe down to the column level, because maybe we don't want to port the entire database right away. We want to break it down into pieces. We want to know what those pieces are. If we're moving code to the cloud and doing this refactoring, we need to know what the components are and how they relate. So here we've got the ability to get a relationship map between inside the application or between objects, which is what I'll do here, or we can search for specific things. And with all these things, we can create a really nice diagram. And what I've done here is I've selected the project, which is my sample, and the file that I'm gonna check it on, and I got the results here. So this is the relationship between my application and the database right here. So my application reads and writes from the database. I can then expand it and see what is inside my application. So I've got an object called sample code, and it's got these specific functions. And I can now see which functions here within my object, within my sample code object, actually reach into the database and does stuff. If I and then same with the database here. So I can expand here and see the columns and see what reads and writes into each one of these columns. And I can now take this and continue doing a diagram. We've got a really nice diagram tool where you can add objects and maybe plan something for the future. These arrows actually tell me what is it we're doing. So this right here is uses the table in a read fashion. It reads from it. This one is a C. That means it creates. So the create user creates these specific rows. And I'll go a little bit deeper into this is called a CRUD matrix, and I'll go into that in a little bit. We've got a more detailed version of it, but I do want to show you how granular we can go with these objects down to the specific operation that each of those functions does on each of those columns. Of course, if I double click, so this is the create user, I can get a little more information about the what we call the inner relationship. So this create user function is called by something called do post. So I know who calls my function. By the way, I can basically do this by expanding the calls. So I can see who calls this specific function, or what does this specific function calls, or what table it uses, what column it uses, and so forth. Going back to this create user, so I can see that there's only one function that calls it, the do post. This is important because if I decide to port this create user function, I need to know what will it break in my program. And the answer is it's going to break this do post. So if I port this to the cloud, I need to check that do post works after the porting, which is kind of good news for me, because I know that nothing else will change, or nothing else will break. There's only one dependency with the create user. And then I'd like to know what is that the create user does. Well, it creates all of these columns. See the C relationship, which means that it's creating all these different columns one by one. And if I double click on it, I will go to the specific line of code right here. So I can see the actual create the create call, or I can double click on the source code to see what is this create user function, and see this information here. So this initial diagram is, and this is dynamic. I've done nothing except basically import the source code into DeltaForce, and I'm getting all these nice diagrams right here. And this is a way to onboard a new developer quickly, because they can just use all these things to understand how the program or the application works. Or I can use it for inventory and refactoring inventory, because now I know what I have here. I've got this function, and I know who calls it, and I know what this function uses, or what other things it calls. And refactoring, because I know if I change this, what else I need to change. This whole thing is dynamic. I can run dynamic searches on the source code and search for specific functions, specific things. Impact level here, it goes into change management. So if I change something here, what will be the impact across my program? Moving on, I'd like to show the code trace. So this is sort of a similar view to what I've showed before, except it is a slightly different type of diagram. And here I've got my functions on the sample code file right here. So the connect, create user, update users that I've seen before. And then what are the specific table columns that they use. So this is the table and a table column that each one of those uses, and who calls each one of those things. So again, this is a very simple function diagram of this do post function right here. And what it's showing me is essentially what are what does my functions look like, who calls what. I can then export it, print it, use it as a dynamic documentation. The problem, and I'm a developer, so I know this unfortunately really well. Documentation gets old pretty much the second it's written. So as soon as you write documentation and somebody changed a line of code somewhere, the documentation is almost obsolete. It's really, really hard to keep documentation up to date, which really sucks, because when as I bring in a new developer into my team, they need they'd have to read up on what is the program and what it looks like without understanding the whole, without reading tens of thousands of lines of code and trying to figure out what's happening. So this is a way to create dynamic documentation on the fly immediately. It's accurate because it's what, it's up to the minute description of the different functions, the different classes, the different objects down to the database table. So that is an object analysis map. Next, I've got the impact analysis, the change impact analysis. So right here, as you can see, we've got a lot of different analysis we can run, and these are sort of static reports that we can run on the application. This first one is, as I said, a change impact analysis report, and it basically says for my application what is the impact on every one of those down to the function level. So here again, I'm still using this very simple sample. It shows me the different files, the different tables, what type they are. So this is a Java source file. This is a table in a database, the different objects, what they are. So I've got, and then what calls, who calls who, basically on all of these things. And this is crucial for refactoring. So with the change impact analysis, I can now figure out, I can look at this and know that if I change a certain function, what will be the impact? What other columns in the database? What are the tables in the database? What databases? What other source files? What other objects will be impacted if I change something? So this is on the program level. I can do it on an object level. So right here, I can select my application, the specific source code that I think I'm going to change, and the object that I'm planning to change. So it could be a field, it could be a method, it could be a class. So let's say that I want to port this sample code class, and I can, I can then filter it down to if I only want to change specific languages. So I decided to port all my C# into a different language. I can filter by that. You can see all the different languages that we support, or in this case, I'll just go for the wildcard. I can now execute it to see dynamically, or I can export it and give it to my team members, and it'll give me the full change impact analysis. In this case, this program doesn't depend on anything, so it's a little bit boring. Let me try and see if I can get something a little more interesting, possibly, or in fact, why don't I instead go into something that relates more to the database. So rather than we've been sort of focused on objects to objects, but I do want to talk about objects to database, because that is something that happens quite a lot. So in this case, I've got the same change impact analysis, but related to columns. So if I was to change my first sample application, what kind of impact will I have on the tables? And then if I wanted to port some of this data again to the cloud, what will break in my application? So this basically tells me again for each of the columns what changes it, where is it in the file, and what type of change does it do. And this is called a CRUD matrix, and I'm going to show a more dynamic version of it in a minute. But CRUD matrix is actually a crucial component for refactoring, from porting from one environment to the other. CRUD stands for create, read, update, delete. And it basically tells you what creates, what reads, what writes, what updates, and what deletes any one of those columns. And I'm saying it's crucial because you might have a line of code that only runs once a year or maybe once a decade. And that line of code, you may not notice that it depends on the database until you actually port it, and that time passes, and then something breaks. We obviously want to avoid that. We want to know exactly what writes into the database or what reads from it, even if it's something that happens pretty rarely. So we rather than do the porting and then wait to see what breaks, we want to be a little bit more proactive with that, and that's the CRUD matrix. It tells us exactly what the dependencies are and what kind of permissions I'll need to give to my new ported code. Moving on, we'll go on to the program specification. So still on the documentation side, this is something that we can generate at any point in time. Again, generate and produce as an XNS file, as an Excel file or PDF or a document that you can later edit. So the program specification takes everything we know about that specific application or that specific piece of code and creates a dynamic documentation from it. So all the objects that are there, what is the constructor, what are different fields, methods, where they are. So you can look them up very, very quickly. Of course, this can be done as in a static version like I'm doing here, or dynamic version that we can double click and get to that specific line of code. The defects, so these are, this goes to the code quality rules that I talked about. So there are some, none of these are critical defects, but there are some things that we don't like, and we've made a notice of them here, and you can later see them in the code as well, and their relationship. So what calls this, what calls connect, and so on. And this is page 1 of the 3 of the program specification. Will there's more, of course, that you can see. So we can immediately produce pretty lengthy documentation about the entire code, the different methods, different classes. This is the CRUD matrix. This is the dynamic CRUD matrix that I've talked about. So for every project, for every line of code, for every object in the system, you can see dynamically what are the different tables and columns that it uses. So in this case, we've got something called my project. It has all these different files. And if I want to focus on this DAO, database access object file that I've written, I've got all these different functions that manipulate the database in different ways. So this customer 20, for example, creates a bunch of all these rows, and then read, writes, and updates this customer 20 row. If I click on it, I'll get what does the read, what does the update, what does the delete. So get data, reads from it, updates, deletes, which is nice, which means I'm documenting things pretty properly. If I want to go to the update data row, I'll double click it, and it will show me the exact line that updates, that runs the update query, and I can see it right here. So I can immediately access any line of code on anywhere on my project. So I don't need to guess anymore or rely on documentation, which may or may not be correct. This is exactly, as of right now, as of the code I've got, everything that updates the database generated dynamically. I can click through and get the data as I need it. Some rule violations. So I've mentioned the code quality rules. There's also security quality rules. We can go down and show the specific issues that were found, and we can show some graphs that show how the quality of the code is over time, which is, again, important. This is especially crucial if you're outsourcing any of your development. It allows you to see what your code quality is like, and how it improves over time based maybe on your feedback or feedback of programs like DeltaForce. When we go into the exact, so this goes into the specific quality rules. So you can see the medium level issues right here. I can drill down and see what is it that the problem is. Again, I'll double click and I'll go to line 46 in the code and see what the issue is. So I can see that I've got this problem. I have the description right here with a flag, a description, an example, everything else you need to figure out. You can then decide if you want to waive that, if it's not that important to you, or obviously if you fix it, it'll disappear later on. This is one of the things I really like in a DeltaForce. There's a lot of interactive diagrams that you can create, then you can manipulate and export in a lot of different ways. This is a flow diagram, and what it basically is, from every piece of code you can receive a graphical representation of what's really happening. So this is what, so if you have ever learned computer science, this is something that we learn on the first year, and unfortunately never do again, because it's really complicated to do by hand, and it's absolutely immensely powerful, and DeltaForce can generate this for you interactively. And what it does basically is shows how does this function doPost works. So I've got a function called doPost. It starts, it runs some code and finishes, and the flow is like this. It starts, there's an if clause. So what is the if clause? I can drill down into it and see that the if clause is if this connection is null. If it is, there's a few statements. If it's not, there's other statements. Later on, I've got the next bunch of statements right here, which I can drill into and see what they are. Next, I've got another if. So here's the if. Again, right here, here are the statements. And I can drill down and see the flow of my entire function here, the doPost function, and drill down into the specific thing that it does. This is probably the best way to train a new developer on what is happening with this function and what it looks like, without them trying to figure out the code, with the nested conditionals and everything else. This really goes sort of line by line, but in a logical way, and helps whoever's looking at it figure out what's really happening. So this is a flow diagram. Again, you can export it, you can edit it, you can annotate it. It's quite scalable. And I'll just finish by showing the many reports that we have. So a lot of dynamic stuff, which I've showed, a lot of static reports that you can do. So source code inspection, as quality inspection and security inspection. Different impact analysis. So these are all what if scenarios. So if I was to change something in the program or the object, what would happen? What would change? All the different documentation down to the program, the function, the methods. You can do some housekeeping stuff like what are tables that are not used, columns that are not used, procedures that are not used, let's get rid of them, and the different analysis that we've got to the specific languages, specific tables. So there's really a lot of things you can produce. Now, as next, what I would like to invite you to do is try it on your own. So we do have a cloud-based platform that we want to invite you to see for yourself, and maybe upload some source codes to get some of these reports on your own code. So rather than take my word for it, try it yourself and see what kind of information we can give you on your own projects, on your own databases. Go to delta-force.net for more information, or contact Stan Yi at delta-force.net to get a demo, to get a POC, to try it on your own. And with that, I'll return the presentation to Stan for some final words.
Great, thank you, Avi. Appreciate that. Richard, thank you as well. I hope we were able to give everyone a brief overview of some of the capabilities of DeltaForce, specifically around assisting application development teams, basically make their lives a bit easier, provide greater visibility, and bringing people onto your team in a speedy fashion and getting them up to speed, essentially providing valuable insight into your entire application environment. So with that said, we would love to show you more, perhaps in a private demo, and answer any questions you might have. As Avi mentioned, please reach out to me at stanyi@delta-force.net, or you can reach me by phone at 650-285-5250.